Hi, 8th grade. Welcome to lesson 6-9, interior and exterior angles of triangles. By the end of the lesson, I want you to be able to say, I can find the interior and exterior angle measures of a triangle. Let's solve and discuss it. Nell cuts tile to make a decorative strip for a kitchen backsplash. She must cut the tiles precisely to be congruent triangles. She plans to place the tiles between two pieces of molding as shown. What is the angle of measure 1? How can you use your knowledge of parallel lines and transversals to solve the problem? Well, okay, first I'm going to redraw this. We've got, pretend those are parallel. And we've got a green triangles. So they all have to be the same triangle. And we know that this angle is 65. This one's 65. So knowing that, these have to be 65. Because remember, they're opposite, alternate interior angles. Then I look here, and what I know about a straight line equals 180 degrees. So 65 plus 65 plus angle 1, that's what we're looking for. We can call that x, has to all equal 180 degrees. 65 plus 65 is 130. So that's just me combining like terms. I subtract 130 from both sides, and x has to equal 50. So that third angle has to be 50 degrees. What assumptions did you need to make to find the measure of angle 1? Explain why your assumptions is reasonable. We had to make the assumption that the triangles were parallel, the backsplash. So we made the assumption of parallel lines. It's reasonable because it's held between two pieces of wood, and wood is cut straight. Example number 1. How can you describe the relationship between the three interior angles of each triangular tile in the backsplash? You can rotate and place the congruent tiles side by side to form an alternating pattern. So we see that angle 1 is in blue, and line them up so they were corresponding. 3 is in green, and 2 is in orange. If we can see, angles 1, 2, and 3 appear to fit together to form a line. There's that straight line. Use what you know about lines, transversals, and angle pair relationships to describe a relationship between the interior angles of a triangle. Interior meaning on the inside. Alternate interior angles are congruent, so A is parallel to B. Since angle 1, angle 2, and angle 3 form line B a straight angle, the measure of angle 1, 2, and 3 equals 180 degrees. All three angles inside a triangle add up to be 180. That's this generalization. The sum, meaning addition, of the measures of interior angles of a triangle is 180. Find the unknown angle measure in the triangle on the right. So we don't know this. This is x. But we know 68 plus 40 plus x has to equal 180. I'm going to combine like terms. 68 plus 40 gives me 108 plus x equals 180. Using my inverse operations to solve for x to get x by itself, I'm going to subtract 108 from both sides. That cancels out, and x is equal to 72. Convince me, could a triangle have interior angle measures of 23, 71, and 96? Explain. So we can check that by adding them all together. 23 plus 71 plus 96 is gonna give us 190 degrees. 190 degrees is no good. So no, because the sum should be what? The sum should be 180 degrees. Example number 2. Find exterior angle measures. In the diagram, the measure of angle 2 is 68 degrees. So this is 68. The measure of angle 3 is 42. What is the measure of angle 4? Well, angles 1 and 4 form a straight angle and are supplementary. So we know that 1 plus 4 have to equal 180. And we know that measures of angle 1, 2, and 3 are the interior angles of the triangle. So together, angles 1, 2, and 3 equal 180. So if angle 1 and angle 4 equal 180, and angles 1, 2, and 3 equal 180, that must mean that the measure of angle 1 plus the measure, to save room, I'm just going to put angle 1. So I'm using these two equations. Angle 1 plus angle 4 has to be equal to angle 1 plus angle 2 plus angle 3. But I see that both of these have angle 1. So what if I subtracted angle 1 from both sides? They would cancel out on the left and cancel on the right. And then we get this. The measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. So, in other words, the exterior angle of the triangle, so the outside of one of the angles, is equal to the other two angles added together. So measure of angle 4 equals 68 plus 42. So the measure of angle 4 is 110. Now that's the short way to do it, but there's a long way to do it that I will prove to you that it works. So going back to what we know that this is 68 and this is 42. And we know that angles 1, 2, and 3 have to equal x. So adding them all together is going to be 180. So 68 plus 42 plus x equals 180. 68 plus 42 is 110 plus x equals 180. We're going to subtract 110 from both sides. So x has to equal 70. So that's this one. So if that one's 70, this one has to be 110 because together they have to equal 180. But to check what we learned here, look at that. 68 plus 42, the outside two angles equals 110. So shortcut is, if you're trying to find this outside angle, all you have to do is the other two angles added together, the sum. So for each exterior angle of a triangle, two of the non-adjacent, the ones not next to them, interior angles are its remote interior angles. An exterior angle of a triangle and an angle formed by a side and an extension of its adjacent side. Example 3, use algebra to find an unknown angle measures. Measure of angle 4 is 7x plus 7. So this is 7x plus 7. The measure of angle 2 is 4x plus 4. And the measure of angle 3 is 4x minus 9. What are the measures of angle 4 and 1? Well, the first step is I know that the outside angle is equal to the opposite angles added in. So that's what they do here. 7x plus 7 is equal to 4x plus 4 plus 4x minus 9. Then they combine like terms. 4x plus 4x gives them 8x. And that's a positive 4 minus 9 gives us negative 5. And just bring down the 7x plus 7. Now you want to get x's on both sides. So we're either going to subtract 7x or subtract 8x. We subtract 7x so that we don't deal with negatives. So subtract 7x from both sides, cancels out on the left. We bring the 7 down. And 8x minus 7x gives us 1x. Bring the negative 5 down. And last but not least, solving for 5, you're going to add 5 to both sides. So x equals 12. But we're not done. We just solved for x. They want to know what actually the measure of angle 4 and 1 are. So the measure of angle 4 is brought on by 7x plus 7. So instead of x, we plug in 12. That's what we found. And solve. PEMDAS, multiply first. 7 times 12 is 84. Then add 7 to get 91. Well, if we know that this outside angle is 91, and we know that 1 and 4 are supplementary, they add up to 180 because they form a straight line. Measure of angle 4 is 91, plus the measure of angle 1 equals 180. Subtract 91 from both sides to get that the measure of angle 1 is 89 degrees. Let's try it. What is the measure of the exterior angle shown? Well, we know that 16x is the outside angle, and it has to be equal to the two others added together. 7x minus 1 plus 8x plus 8. Combining like terms, I have 7x and 8x. I have a -1 and a +8. So I bring down the 16x. 7x plus 8x is 15x. -1 plus 8 is +7. Solving for x, I'm going to subtract 15x from both sides. You wouldn't want to subtract the 16x because that would leave nothing on the left-hand side. So this is just 1x equals 7. So x equals 7, but that's not what we're asking. What we're asked of. It wants to know what the measure of the exterior angle is. Well, that's 16x. So instead of x, I'm going to put 7. 16 times 7, I think is 112. Let's just see. 16 times 7. Yep, 112 degrees. On the next page, the key concept. The sum of the measures of an interior angle of a triangle is 180 degrees. So the measures of angle 1 plus 2 plus 3 equals 180. The measure of an exterior angle, so the angle on the outside of a triangle, is equal to the sum of the measures of its remote interior angles. So angle 4 is equal to the opposite two angles added together. It is not equal to the angle next to it. So 4 is equal to 2 and 3. Okay, 8th grade, let's say it. I can find the interior and exterior angle measures of a triangle. Have a great day.